adjust the power, that is x by 2, it becomes 4e, and remaining power, that is nothing but 2. So in this way we can simplify our sum. Here limit x tends to infinite 1 plus 1 upon x. If you apply the limit, now before apply the limit just compare. Here x tends to infinite, here n tends to infinite, here 1, here 1, here 1 upon x, here 1 upon n, here s to n, power that is inverse, here x. So finally we can got answer, that is e. So apply the limit, put the equal to sign, and all answer of the numerator, that becomes e. Divide by, same way limit x tends to infinite 1 plus 2 by x, power inverse x by 2. So this value answer, this is nothing but e. So if this value, that is e, and remaining power, that is 2, so that is e square. So finally e divided by e square, 1e and 1e cancel out, and remaining 1e in denominator side. So finally we can got our answer, that is 1 upon e. So we write it our answer. Our answer value, that is 1 upon e. Now we move to our next question. Our next question, that is limit x tends to infinite n plus 3 divided by n plus 2 raised to n. Like as our previous sum, n tends to infinite, n plus 3 divided by n plus 2 raised to n. So first step to write it, limit n tends to infinite, n plus 3 divided by n plus 2 raised to n. So here n tends to infinite, our base formula suggests that whenever limit n tends to infinite, inside the bracket 1 upon n. So again we divide all the value by n. So again step, that is repeat. Here limit n tends to infinite, n plus 3 divide by n, same way n plus 2 divide by n, put the power, that is raised to n. Same procedure, this n goes to both this side. So n divide by n, that is called 1, plus 3 divide by n. So we write it, limit n tends to infinite, 1 plus 3 divided by n, because this n divided by n called 1, and this n goes to 3 side, that called 3 divided by n. In this way denominator, that is 1 plus 2 by n, here raised to n. Now next step, to apply the power both the side, numerator as well as denominator. So our next step, that is limit n tends to infinite, 1 plus 3 by n raised to n divided by 1 plus 2 by n raised to n. Now next step, that is adjust the power that we want. Here 3 by n, here we want inverse power, that is n by 3. So we require to adjustment of the numerator power. Same way here 2 by n, and we want n by 2. So again next step, that is we want adjust the power. So next step, that is adjust the power both the side. So here limit n tends to infinite, 1 plus 3 by n, and write it what we want, that is n by 3. And now just check it with actual power, here n, here 3, but here not any 3 value, so multiply with 3. So finally this 3 and this 3 cancel out, and remaining power, that is same, divide by 1 plus 2 by n, and what we want, that is n by 2. Now just compare it with actual power. Here n, here n. No any 2 value with divide by n. So finally we want to multiply with 2. So this 2 and this 2 again cancel out, and remaining power, that is same. Now next step, that is apply the limit. If we apply the limit to numerator as well as the denominator, so we can write in this way: limit n tends to infinite 1 plus 3 by n, n by 3, here bracket complete, and here remaining power, that is 3, divided by same procedure, limit n tends to infinite, inside the bracket 1 plus 2 by n, n by 3, sorry, n by 2, and remaining power, that is 2. So now just use our base formula, that is n tends to infinite 1 plus 1 upon n raised to n, that we call e. So here n tends to infinite 1 plus 3 by n raised to n by 3, that we call e. So remaining value, that is here if e, then power remaining, that is only 3. So e raised to 3. Apply the limit, put the sign equal to. Same way in denominator side, limit n tends to infinite 1 plus 2 by n raised to n by 2, that we call e. So this call e, and put the remaining power, that is 2. So finally 3 times e, here 2 times e. So finally we can got only e. So e, that is our final answer. So we can write it, our answer value, that is e. Now we move to our next question. Our next question, that is limit n tends to infinite 2n square plus 3n plus 1 divided by n cube plus 3. So first of all we write it first. Here limit n tends to infinite 2n square plus 3n plus 1 divided by n cube plus 3. So here n tends to infinite. Based on our previous all example, we suggest that whenever limit n tends to infinite, then 1 upon n form, that we want. If we want 1 upon n form, then divide and multiply with its maximum power. So here n values maximum power, that is 3. So divide all the term with n cube, that is numerator value, that is divide by n cube, and denominator value, that we want divide by n cube. So we can write it, limit n tends to infinite 2n square plus 3n plus 1 divide by n cube, all divide by, write the denominator, n cube plus 3 divide by n cube. So finally this n cube cancel out, and remaining problem, that is same. So our next step, that is apply the n cube to both the side, that is 2n square divide by n cube, 3n divide by n cube, and 1 plus, that is 1 divide by n cube, all divide by, apply the denominator side n cube divide by n cube plus 3 by n cube. So our next step, limit n tends to infinite 2n square divide by n cube plus 3n divide by n cube plus 1 divide by n cube. Here n cube divide by n cube plus 3 divide by n cube. So now we want to solve the n cube value. Here limit n tends to infinite as it is. Here n square, here n cube. So 1 n that is remaining in denominator side. So that is becomes 2 by n plus value as it is. Here n cube. So in denominator 2 n cube that is remaining, that is 3 by n square. Here we write as it is 1 plus 1 divided by n cube. So our next step, that is solve as well as our denominator, that is divide by, here n cube divide by n cube, we can got 1, write this value as it is, plus 3 divided by n cube, 3 divided by n cube. Now apply the limit, because we are ready to apply the limit. Whenever n tends to infinite, our base sum also suggests that whenever n tends to infinite, 1 upon n that we call 0. So using this formula we applied the limit n tends to infinite, 2 by n that we call 0. So we can write it, this applied the limit n tends to infinite, 2 by n, plus apply to second one, limit n tends to infinite, 3 by n square, apply limit to third one, n tends to infinite, 1 upon n cube, all divided by this one as it is, plus limit n tends to infinite, 3 by n cube. Here 1 upon n form that we call 0. Here again 1 upon n square form, limit n tends to infinite, that we call 0. Here again 1 upon n cube, that is 1 upon n form, limit n tends to infinite, that we call 0. So finally we can go applied the limit, first one 0, applied the limit second one, that we call 0, applied the limit to third one, that we call 0, divided by 1 as it is. Same way 3 divided by n cube, applied the limit, that we call 0. Finally 0 divided by 1, and we can go to answer, that is 0. So we write it our answer value, that is 0. Now we move to our next question. Our next question based on this formula, limit theta tends to 0, sin theta upon theta equal to 1, and limit theta tends to 0, tan theta upon theta equal to 1. Whenever we want to solve the trigonometric type form, then apply 1 minus cos theta equal to 2 sin square theta by 2, and 1 plus cos theta we can write 2 cos square theta by 2. So first of all we write it, our base limit theta tends to 0, sin theta upon theta equal to 1, same as limit theta tends to 0, tan theta upon theta equal to again 1. This is the two basic formula. Same way we can write 1 plus cos theta equal to 2 cos square theta by 2, 1 plus cos theta 2 cos square theta by 2, but when 1 minus cos theta we can write 2 sin square theta by 2. So now next problem, that is based on this formula. So our next question, that is limit x tends to 0, sin inverse x into 1 upon x. So first of all we write it, limit x tends to 0, sin inverse x divided by 1 divided by x. So that is divided by x. Now what is our base formula? That is nothing but whenever theta tends to 0, sin theta upon theta equal to 1. So first of all, sin inverse x, let assume theta is equal to sin inverse x. So ultimately sin theta becomes x. So in this way we want to convert our numerator first. So next step, that is assume with sin inverse x equal to theta. So let sin inverse x equal to theta, then ultimately x equal to sin theta, because this inverse goes to multiply with theta. So finally that becomes sin theta. Same way, if we change the x and convert into theta, then our limit must be changed. When x tends to 0, then now put the value here, sin inverse 0, we can got sin inverse 0. So in this way, this we call equal to theta, at which angle the sin becomes 0, that is 0 equal to theta. So in this way we can write, when x tends to 0, theta tends to 0. So next step, that is nothing but change the limit, because here we assume x sin inverse x equal to theta. So now write x tends to 0, theta tends to 0. So next step, that is theta tends to 0. Here sin inverse x, we assume value, that is theta. So write it just only theta. Here into multiply as it is 1 as it is x. Same way assume value, that is theta. So convert it with to theta value. So x, that is nothing but here sin theta. So write it here sin theta. Now just again next step, that is compare with our base sum or base formula. That is nothing but limit theta tends to 0, sin theta upon theta equal to 1, but here theta upon sin theta. So next step, that is just same question but in different look. So limit theta tends to 0, this theta that we apply to denominator. So